This question is from GATE Mechanical Engineering of 2014. This is question number 46 of set 2. The question is, in an ideal Brayton cycle, atmospheric air whose specific heat ratio is 1.4, specific heat at constant pressure is 1.005 kilojoule per kilogram Kelvin, at 1 bar pressure and 300 Kelvin is compressed to 8 bar. The maximum temperature in the cycle is limited to 1280 Kelvin. If the heat is supplied at the rate of 80 megawatt, the mass flow rate in kilogram per second of the air required for the cycle is. Let's see the TS diagram of ideal Brayton cycle. This figure represents the TS diagram of ideal Brayton cycle. 1 to 2 and 3 to 4 are isentropic process. 2 to 3 and 4 to 1 are isobaric process. Okay. In 2 to 3 heat is added to the system, and 4 to 1 heat is rejected from the system, or we can say rejected from the cycle. Now in the problem it is given that P1 is 1 bar and P2 is 8 bar. Okay, so process 2 to 3, I have already said it is constant pressure, so this is P2 and this heat is rejected at the pressure P1. Also the temperature T1, initial temperature is 300 Kelvin and the maximum temperature, that is T3. So T3 in the problem is 1280 Kelvin. Also in the problem it is given that heat added into the system is 80 megawatt. The specific heat ratio gamma is 1.4 and the specific heat at constant pressure Cp is 1.005 kilojoule per kilogram Kelvin. Okay, these information are available in the problem. Now we know that process 1 to 2 is isentropic process because the entropy remains constant. So it will follow the isentropic relation. Let's write down the isentropic relation for process 1 to 2. T2 by T1 should be equal to P2 by P1 to the power of gamma minus 1 by gamma. Therefore, we can find the value of T2 from here. So T2 will be equal to T1, that is 300 Kelvin, multiplied by P2 by P1. P2 is 8 by 1. Gamma is 1.4 minus 1 is 0.4 divided by 1.4. So from here, T2 will be equal to 543.43 Kelvin. Now the heat addition in the cycle Q in or Q add can be written as mass flow rate into Cp, specific heat at constant pressure, multiplied by T3 minus T2. Okay, because heat is added between 2 and 3 at constant pressure P2. Alright. Now all the information are given here, so we can find mass flow rate from here. So m dot will be equal to Q added heat or generated heat, we can say, divided by Cp T3 minus T2. Therefore heat added is 80 megawatt, so we can write 80 into 10 to the power of 6 watt whole divided by Cp is 1005 joule per kilogram Kelvin, multiplied by T3 minus T2, and T3 in the problem is 1280 Kelvin, 1280 minus T2 we just found out 543.43 Kelvin. Okay, so from here we can get the value of mass flow rate, and that will be equal to, using digital calculator we can get this value. This will be 108.07 kilogram per second. Okay, now let's fill in the blank. So the mass flow rate of air required in the cycle is 108.07 kilogram per second. For more information on Brayton cycle, you can refer to the NPTEL course lecture number 62, Brayton cycle on concepts of thermodynamics, by Professor Suman Chakraborty of the Department of Mechanical Engineering at IIT Kharagpur.